Hello everybody, how are we all doing? Quick video of some faults that may or may not be interesting, or you might come across something similar. It might just help you sort of get to the bottom of it. But basically, what I've got behind me is the internal piping diagram of our Sideflow 3-pipe VRF. So these are the pipework is exactly the same, but it's between a RAS 8 to 12 FSXM NME. So basically, these come out of the factory as a 3-pipe, and if you want to use it as a heat pump, you just get two, set a dip switch, and it's a heat pump. So they come out of the factory like this. So normally, if you're doing it as a 2-pipe, what you do is you connect into your liquid line here, and then you're going to connect to your high and low. So your high and low pressure is going to be used as a discharge and suction, depending on what mode it is. And then if you're using it as a 3-pipe, you're going to connect your suction pipe to the common suction. So basically, when these systems are used in cooling only, or if you're in all your indoors units being used for cooling, it's going to use both of these pipes as a common suction. Because as you can see, your suction comes along here, and then drops down towards your accumulating compressor. Now, if it's all the indoor units are in cooling, it's going to also come along here through the four-way valve and drop into the common suction and back. So what happened on this site was they'd accidentally crossed the high and low with the suction. So when the system's been cooling, both of those pipes being used. So if you're unfamiliar with our service tool, this is it. It's pretty inexpensive. So basically you can do control mode or monitor mode. So because we had a few delays, we had to set up the BMS first. So the BMS was connected. So ideally, you don't want to controlling devices because it doesn't always show the details properly. So we're in monitor mode, so we've got a bit less information, but we can see all our indoor units. So where it says RTS, this is what our controllers are showing. So we can see we're on in cooling mode. So we're actually in test, so we ignore the set temperature. And the unit itself is in cooling mode. We've got the fan speeds quite low at the moment, but we can see we're in thermal on. So we can see our inlet temperature. So we know they're quite low. It's still a bit unsafe, it's still quite cold, but we can also see our outlet temperature. So on Hitachi Utopia units and our VRF units, they all use what's called set-free indoor units, and they have an outlet thermistor, so we can actually see what the unit's actually outlet temperature is. So we can, just off the cuff, we can see that it's cooling. Below that, we've got our remote control temperature. Now that won't display if the remote control isn't being used to use for inlet temperature effectively. If you want to know what your control temperature is, down here we've got our TI and TG. TI is your liquid temperature, so this is just after the expansion valve, so that's giving you your saturation temperature, and then TG is your gas pipe temperature. So from there you'd work out your superheat subcooling depending on what mode it's in. So we can see that we've got some superheat. Expansion valve, always done a percentage, so it gives you a good indication of how far open they are. So we can see just off there that the system doesn't cool. Now the problem is when the system goes into heating. So we can see that the controls are showing heating, and we can actually see that the indoor unit itself isn't heating. Now the fan has stopped. The reason that is because it's waiting for the coil temperature to get up. But because the system is obviously clearly cooling, so we can see that inlet temperature is obviously still pretty low. We do have more information on the outdoor unit, but because we've got the central controller, it's just conflicting a little bit and it's not displaying anything. But the main information is we want here. So we can see the outlet temperature is obviously low, so we're obviously in cooling. Now the expansion valve is 100%, 72 on that one, because it thinks it's in heating mode, so it's open expansion valve. Our liquid temperature now, we've got the gas temperature obviously in the minuses, so we know that liquid refrigerant is boiling off and it's flowing straight through that unit. So the systems have gone into cooling. Now the reason that is because we've got these two crossed over. When the discharge gas is going out, so it's coming out of here, but it's actually going into the suction. So these are the internal piping diagrams of our changeover boxes. So discharge gas is actually being pushed through there. Now suction gas is being pulled through there. Now what should have happened was your low pressure is always going to be your suction, and then your discharge gas. In a normal situation, discharge gas would come through here. Your MVD for each indoor unit would open up, push discharge gas through into your indoor unit, and then back as liquid. Now, because we've got crossed over, so in these boxes, they all use expansion valves to reduce noise. But you've got no valve other than on your liquid pipe other than your indoor, so it always works off a pressure difference. Now, because that's discharge valve is going to be open to heating. That opens it up, but because the pipework is crossed, it's suction pressure on the other side of there. So the discharge was building up quite quickly because it's hitting these expansion valves and they're all closed. And then the units were going to cooling because that valve would open, suction gas on the other side, and it would go into cooling rather than heating. So you would have an instance where all your indoor units would start to cool and then you'd have liquid flooding back. So it was just a result of the pipeworks being crossed on there. So if you do have a system that's brand new, or if it worked fine in the summertime, but as soon as it goes into any units go to heating, you're getting this problem, then just check that they've actually connected the pipework up correctly on the outdoor unit. As soon as we poured down the lagging, it was fairly obvious. It was 1/8" suction and 7/8 discharge or high and low pressure. So as soon as they were swapped over, it was fine. Now the other thing we noticed was we had a restriction on the liquid line. So when the system was in heating, so it was the same system unfortunately, when the system was in heating, we can see that we're in heat mode, got high fan speed, so we can see that the gas pipe temperature is starting to build up, so 36 degrees, 31 of those ones. Temperature is starting to get warmer. Now, liquid temperature between 18 and 19 degrees, so your liquid temperature should never be colder than your air inlet temperature. Now, on the outdoor information, we can see that the discharge temperature has got very high very quickly. We can see that the pressure ratio is quite a lot. So megapascals, if you want to move it into bar, just move the decimal place over. So it's actually prohibiting any increase because it doesn't want as high as a compression ratio. Now, the big thing on here is, so on here, as your gas pipe comes, your liquid temperature comes back through here. It's going to come through on here, then we've got two thermistors here and here, because in between here we've got a mechanical subcooler. So we've got TCHG and TCS. So we've got a liquid temperature of 18, 19, 20, 23, but we can see that our liquid temperature in the units is at 4 degrees and 0 degrees. So we've got a huge temperature difference from the indoor to here. Now, if that pipework was exposed and it was in minus temperatures outside, then possibly. But there's a huge temperature difference between there. The other thing is as well is we've got TG1 and T1, which is your outdoor coil thermistor, and our saturation temperature. So because this is when the system's in heating, this is going to be used as your evaporator. You've got TE, so that's just after the expansion valve, so that's your saturation temperature, and TG, so that's going to be working on your superheat. So as you can see, really high superheat, so that outdoor coil has been starved of refrigerant. And the system actually went into defrost mode because it could see that T1 was so low, it assumed that the outdoor coil was icebound, even though the ambient temperature was not that cold. But what you could feel as well is when you put your hand just towards the service valve, you actually feel it pulsating. And what it was the 3/8 half-inch liquid that drops down to 3/8. There's a factory stub with a swage, so all you need to do is braze onto it and then connect your flare on. Now, there was a 10-degree difference between that point there and the pipework coming in, and at one point it did start to frost back. So likelihood it's probably left the cap in on the pipework as of brazed, and that's caused a restriction. But yeah, if you ever have a situation where your indoor units liquid temperature is pretty close to what your air inlet temperature or higher, but your outdoor unit liquid temperature is very, very low, then likely that you've got a restriction on your liquid line. So yeah, so I hope that helps. If you come across it, it'll be interesting on whatever things you've picked up. But yeah, hopefully that helps if you've ever run into that situation. Hopefully you don't, because it is a massive pain, but there you go. Right, cheers guys, have a good weekend, bye bye.